add, sit down. Let's say we want to add fractions. What do we need to do to add fractions? What do we need?
You need a common denominator.
Common denominator. Okay, so if I have A over B plus C over D, I need a common denominator. What would my common denominator be?
BD.
Okay, B, D, and then BD over here, right? So I would need to multiply the top over here by D, and I need to multiply the top over here by B. Okay? So that's how we add fractions. You need a common denominator. Then we can rewrite this as AD plus BC all over BD. Okay? I'm just going to give you the generic formulas here. What if I wanted to multiply fractions? Carefully. Going across multiply if there's an equation. Let's say I had A, B times C, D. What does that turn into if I'm going to multiply fractions?
AB.
Nope.
AC, I mean.
AC.
No.
Yeah.
Over BD.
Wait, are you cross multiplying?
Over
or straight
BD.
across?
Straight across. Okay. So multiplying fractions, you go straight across top, straight across bottom. Okay. What if I want to multiply radicals? Multiply radicals. Let's say I have A radical B times C radical D. Does anybody know what I have to do with those? A times C. What goes under the radical?
Because under the radical would be, let's see, AC, BD.
B times D.
Which one would be?
B times D. Okay, DB, same thing.
Let's just write this down.
All right, I would. So when I'm doing this, I'm assuming, guys, that A, B, C, D are all real numbers. Okay, so they can be anything they want to be, essentially. Okay, and that's the approach that I would use. If I want to add radicals, which also incorporates subtracting.
Wait, so when you say this is due, the one paper is due Friday, do you mean Friday when you get to class or Friday at 9?
Right now, Friday when you get to
Typing it in
class.
the Math Excel?
Yeah.
So you have to do it tonight or tomorrow day.
If I want to add or subtract radicals, this is the way it's got to be. I have A radical B plus C radical B. Notice that the radical part is what?
The same.
The same. When that's the case, I can rewrite this as A plus C
Plus A plus B.
radical B. A plus C radical B. If they are different, for instance, I have A radical B plus C radical D, then my answer is A radical B plus C radical D. I cannot condense it any further than that. Those are the ways that we add and subtract radicals. If it was subtraction, the A plus C just turns into A minus C. Those are really the rules that we need to work with and understand so that we can be able to navigate not only through this worksheet, but through a lot of the things that we're going to do in the future. Okay? And I mean future, I mean kind of the immediate future. Okay? Within the next couple weeks and months. If we are going to, just multiplying some radicals here, guys, if I have, I might want to add a little note here that BD will most likely need reduced. Okay? Or simplified if you want to use that terminology. Just an example. What if I had 3 radical 15 times 4 radical 3? 5 would have been fine as well. So the numbers on the alpha side, A and C, are, in this case, 3 and 4, right? So what's 3 times 4 give me? 12. So I multiply the numbers on the outside. Now I'm going to multiply the numbers on the inside. What are the numbers on the inside going to give me? 45. Now, that 45, if I think about it, does that 45 have a perfect square that will divide it?
Yeah.
Well, perfect square will divide it. 9. So 12 radical 9 times radical 5 is the same thing. Does that make sense?
Yeah.
What's radical 9, though?
Radical 9, 3.
3. So now I have 12 times 3, which is
6.
36. So 36 radical 5 is that product, and that's the best way to write it. If I were adding radicals, let's say I have 5 radical 3 plus 6 radical 3. What's that give me?
5 times 6.
Careful. Adding. If you took 5 times 6, what do I really want to do?
11.
5 plus 6, right? So 11 and then radical 3. Okay. What if I had 5 radical 3 plus 6 radical 2?
Leave it at that.
I leave it as that. That is the simplified version. Okay. And maybe something that you can draw a comparison to is that let's just say that I had, let's say radical 3 is equal to x and radical 2 is equal to y. So then I would have 5x plus 6x. What did I? And do we know that makes 11x? Well, if I looked at this 5 radical 3 and I wrote that as 5x and 6 radical 2 as 6y, can I add those two things together? Can I add 5x and 6y? No, they're different variables, right? They're not like terms. So when I'm adding radicals, the radical part, which is called a radicand, that number underneath the radical, they have to be identical for us to add the coefficients up. And that's all you have to do. Okay? Subtraction, all you do is subtract the coefficient. All right. Those are some rules that we need to commit to memory. I'll show you another one here in a little bit that we have to use. Dealing with radicals and denominators. Okay, so that being said, let's look at a couple questions off of the worksheet. We showed this the other day. I think it's a good idea that you guys have that written somewhere. That's the rules that are going to set up our proportions. Okay. So now look at the worksheet. Are there any specific questions that you guys want to go over? I want to do 10 and 14 specifically.
Take a peek at this.
So as we're doing 10 and 14, okay, 7. Let's do 7 first. If we look at 7, says
3.
LK is 3 radical 6. And MK is 6. Find JM. Okay. When we do these, remember the first thing to always think about is these 3 segments. Okay. The legs of your right triangle, the altitude, and the other leg. Okay. Right now, of those 3, they give me that one, right? So they give me a leg. And if I look at this equation down here, it says if provided a leg, the leg goes in the denominators. So, or sorry, not denominator, in the means location. So 3 radical 6 should go there, and 3 radical 6 should go there. Does that make sense, everybody? Okay. Then what goes here is the whole hypotenuse. What is the whole hypotenuse here? X plus 6. And now what is the part of the hypotenuse that's touching the blue leg that we used? 6. So now I'll cross multiply 6x plus 36, right? Now here's where these rules that we talked about at the beginning, here's where this rule of multiplying radicals comes into play. Okay? We need to multiply 3 radical 6 times 3 radical 6. So I multiply the numbers on the outside. What's 3 times 3? 9. And then I multiply the numbers on the inside. So 6 times 6 gives me 36. Now we always got to look at that product. Say, okay, 36 Does it simplify? What is the square root of 36? 6. So that does simplify to 9 times 6, which gives me what? What's 9 times 6? 54. I'm going to stop there. I'll let you continue to work to figure that out. But throughout the day, people have had this question. It's because they weren't sure of how to multiply those radicals. Okay? If we... Good. We'll look at question 10. There's a couple different ways of doing this. It's ultimately up to you. But in regards to the algebra, let's go ahead and you want to solve for
X.
x?
Yeah.
Okay. So x is that altitude in the middle, right?
Yes.
So what should go here? Okay, which one do you want to put?
1/3.
1/3 is fine. What do you put here?
1/6.
1/6. Okay. When I cross multiply, we get x squared equals. Now, how do I multiply?
Common denominator.
Careful.
Come on.
You could, but it's going to make things a lot bigger.
You just go straight across.
You just go straight across. 1 times 1 gives me 1. 3 times 6 gives me
18.
18. Okay? Now, we don't necessarily like that. Okay? Because when I take the square root, I'm going to get this. Does that make sense to everybody? And then we know, we've talked about this before, that if I have a fraction underneath the square root, we can do that. Just like if I had a product, if I had like 2 times 18 underneath the square root. Can we break that up to radical 2 times radical 18?
Yes.
So same thing happens with division. Okay, we can break the numerator and denominator up, and it's really for the same algebraic reasons. Now, I don't like leaving my answers with a radical in the denominator. Okay, and you've probably heard this word before. It's called rationalizing the denominator. Okay, it's the approach that we use. It's the concept that we use to explain that we don't like this number here to be an irrational number. Irrational numbers are numbers that do not repeat as decimals and they do not end, right? Okay, so this one does some crazy stuff. We would like that to be a number that is rational. So whenever you see the word rationalizing, it means using algebra to turn an irrational number into a rational number. A rational number is anything that can be written as a over b, where a and b are integers. Okay, and capital Z is what we use to show integers. Integers are 0, 1, 2, 3, 4, 5, 6, and their opposites, right? So -1, -2, -3, -4, on infinity. So we want to see if we can turn in this 18 into that number. And the way you do that is you multiply by 1. Because multiplying by 1, what does that ever do to something? If I have 12 oranges and I multiply by 1, how many oranges do I have? 12, okay? If I have 13 oranges and I multiply by 13 over 13, what do I have? If I have 13 oranges and I multiply by 13 over 13, how many oranges do I have?
13.
13. I just multiplied by 1, right? 13 over 13 is 1, correct? So if I have radical 18 and I want to get rid of that, the way I do that is I multiply by a convenient value of 1. And that convenient value is determined by whatever that number right there is. Because what is 18 times 18?
Oh, geez. Well, 8 times 8 is 64. 264.
324.
324. Okay, so 18 squared is 324. Well, square root of 324 is
18.
18. This product right here, maybe you can write it this way. It's 18 times 18, right? Does that turn into this, 18 squared? Does that square root and that power cancel out and just leave you with 18? Okay, so when I want to rationalize, I want to turn an irrational number into a rational number, I basically multiply it by itself. So I get 18 there on the bottom. Now up top, radical 1 times radical 18, numbers on the outside multiply together. So the numbers on the outside are these understood ones. So 1 times 1 is 1, right?
Yeah.
And now 1 times 18 gives me 18. Does that make sense to everybody?
Yeah.
Now here's the problem. That's not the answer. Because whenever I multiply and get a radical, I always got to double check to make sure that radical has the largest perfect square divided out. Is there a perfect square that will divide 18 evenly? 9. So 18 looks like that, right?
Yeah.
But radical 9 is
3.
3. Okay, so we get that, right? That is still not the best answer.
Because the 18 on the bottom.
Yes. So what happens here?
Be 3 radical 2 up to 3 radical 2.
No. Because that will develop a radical on the bottom again. This is the rationalized version. It's just not simplified. Would you guys agree that 3 radical 2 over 18 is the same thing as 3 over 18 times radical 2 over 1? If I multiply straight across the top, do I get this numerator? If I multiply straight across the bottom, do I get that numerator?
Yeah.
So what's 3 divided by 18? What does that simplify to?
1 over
1/6, okay? So we can actually reduce that 3 and that 18 and get radical 2 over 6. And that is the best answer for y. Because what we're going to eventually do, maybe we're going to find the area of this triangle later on in the next couple chapters. That means I have to take that number y and plug it into another formula, do other operations with it, and it's going to be so much more convenient to do those operations with radical 2 over 6 than it is with radical 1 over 18. Okay? Now you might say, well, how is that going to be more convenient? 'Cause that was a lot of work, and I agree with you. With the amount of work that I would have to go through to do additional calculations with the square root of 1/18 is
way more.
yeah, it's way beyond the work that we just did. Okay? So keep those things in mind. That's why we simplify things. Think about this. If I had 8 over 4 as an answer, and then I had to take that and use it somewhere else in another calculation, what would I probably be more successful or more appropriate to use in those other calculations? Yeah, I'd rather use 2, right? 8 over 4, which is in decimal form 2. That would be a much better number to use for other calculations. So that's why we simplify fractions. That's why we reduce fractions. That's why we're going to simplify radicals. Okay. So keep those things in mind as we move through. And again, you're going to see that kind of stuff as you progress throughout this worksheet and a lot of other assignments that I provide you guys with. I'm just going to help you solve for z real quick, or at least set it up. If I was looking for a z, that's a leg, right? So it goes there and there. Now, the whole hypotenuse should go here, correct? How do I get the whole hypotenuse? I need to add those things together. Okay, so what did you do there, Charlie? Yeah, common denominator. So I need to make that 1/3 to 6. Charlie sees it, and that's 3/6, and he went ahead and reduced that for him. Great idea to do that.
Wait, so the one where we have to add it is that one where we have to add it at the top?
That's when we're finding z. That's when the leg is
Okay, and
the
then
geometric.
the hypotenuse added together.
Now, the reason we did this 1/3 plus 1/6 up here is because we're focusing on a leg, right? So focus on a leg, I'm using that formula. And I need the whole hypotenuse. Well, the whole hypotenuse is from here to there, which would be 1/3, right? And then to there, which is another 1/6. So 1/3 plus another 1/6 is why I wrote that way. And then in this spot here, it becomes the part that is touching the leg that we decided to use. Are you guys seeing, and just kind of maybe think about how you deal with stuff and how your comfort level, are you seeing how, especially if maybe, what are you doing? No.
I've been answering questions and
I
everything.
don't care. Are you seeing how, the algebra is usually what causes issues, right? Are you seeing maybe the benefit of, it's kind of hindsight. If you now as a geometry student could retake Algebra 1, would you have worked a little bit harder and paid more attention in Algebra 1?
I want to say that I would,
Chuck.
but I know I would not.
Chuck.
But you would want to,
Don't
wouldn't
say
you?
that.
Whether you would or you would want to, right? Okay.
Knock it
So
off.
that's my, hopefully, my insight for you as you go into other courses, okay? Especially mathematically designed courses, because everything's a prerequisite, okay? Geometry is a prerequisite for Algebra 2. Algebra 2 is a prerequisite for college algebra. College algebra is a prerequisite for trig, okay? And in all of those, so if I'm in trig, then the previous 4 classes are important for trig. And if I tank it in one of those, there's going to be an aspect of that class that I struggle with. Okay, so keep that in mind as you move forward through this course. I think it's seen the most with algebra. Okay, and I think it's because we were freshmen when we took it, right? Or maybe 8th graders when we took it. We just don't know high school yet. We're not comfortable with the whole way high school works. We're used to maybe in 7th and 8th grade, teachers doing a lot for us, holding our hands a lot, right? We need, hopefully, to open our eyes to that idea that in math courses, in science courses, previous classes are important, okay? You're not going to start next year from scratch in Algebra 2. You're going to use a lot of stuff that we use in Algebra 1 and a lot of stuff that you use in geometry, okay? If I'm looking at 14, when I do 14, let's just go ahead and start with looking at y. So y is the geometric mean. Okay, it's a leg, right? So that should go here and there. Now, it's the geometric mean between the hypotenuse. What would you call that hypotenuse?
X radical 2.
X plus radical 2. Okay. Now, what should go here?
2.
Is the test going to be easier
Or
than
X.
this worksheet?
It should be x. Okay. Now, looking at that, because that has to be the part of the hypotenuse that's touching the leg y, right? Okay.
Right? I think so.
If I go through, now look at that equation. That equation is going to be hard to solve, right? So don't even deal with it yet. See if maybe we can solve for x or y in another one of these proportions, and it'll make this one a little bit easier to kind of manipulate. So let's look at this z. That's an altitude, right? So it should go here and there.
Yeah.
Now what should I put here?
X.
X,
And then X plus
And
radical
then
2.
2 radical 2.
just radical 2. Okay? Remember, we've talked about this. We're looking for that, the T that is shaped out of those colors, right? Okay, we're comparing those 3 parts. Can I solve for x or z there?
Oh,
Nope. So then I look at the remaining leg, and that should be a geometric mean as well. So 2 can go here, and 2 can go there, right?
yeah.
Now what would this entire hypotenuse be? Yep, x plus radical 2. But now what goes here?
Radical 2.
Radical 2. Okay? So it's always the hypotenuse, and then the part of the hypotenuse that is touching 2, or the leg that you used. Okay? So, which one of these equations has one variable in it? The last one. So that's the only one that I can really solve for anything. And I'm gonna take this work up here. If I cross multiply, I get 4, right? For my my means. Understand that radical 2 is just a number, okay? But if I look at radical 2, let me show you.
Just radical 2.
Mm-hmm.
now if you're fluent in Spanish, are you allowed to do it?
All right, guys, if I look at radical 2, that's that number all the way out to 15 decimal places, okay? Do you see a pattern there with that number? Are there numbers repeating or anything like that, or a series of numbers repeating?
Yeah. No.
No, that's an irrational number. So, that the calculator here is only able to go out 15 units, or 15 place values, but it should go out an infinite number of place values. Does that make sense? So there's an infinite number of decimals after that 5. There is absolutely no way that we could write that out, okay? If we want to be able to work with equations and we have exact answers, does that make sense?
Yeah.
So some of you might say, well, I could round that to 1.4, get an answer, but that answer is not exact. It's got a rounding error incorporated. So we don't want to replace radical 2 with 1.4 in our algebra, okay? But I'm going to use that understanding to kind of help you manipulate how you would do this process. When I multiply here, let's say that this was 1.4 and this was x plus 1.4. Why don't you take this 1.4 and distribute to the x plus 1.4? Okay, so do the same thing, but do it with the version of radical 2. Radical 2 times x is going to look like that. Okay, if you write it this way, that's fine, but there's question of whether the x should be under the radical or not. Or if I write the x out in front, there's no debate of whether it should be under the radical or not. This is essentially a coefficient. Does that make sense to everybody? Okay. And now I'm going to take the radical 2 and multiply it by radical 2. What's radical 2 times radical 2? 2. So now I'll subtract this 2 from both sides, and it gives me 2 equals x radical 2. Now I'm going to draw a comparison. So don't write this down unless you want to. But 2, I could write this as 1.414x. Does that make sense? How would you solve for x if you were using this decimal version? Yeah, you divide by that number right there, right? Well, up here, that number is that one right there. Does that make sense? So, what should I divide the right-hand side by?
1.414.
Which is, as a symbol, it's that radical 2, isn't it? Divide by radical 2. Always divide by my coefficient, right? To solve for x.
Yeah.
That's my coefficient. Cancels. Come over here. Divide by radical 2. So now x ends up being 2 over radical 2. What's the problem there?
You can't have a radical in the bottom.
Okay, so what do I multiply by?
Radical
Radical what?
2.
Radical 2 over radical
2.
2. Because what did I just multiply by? What's radical 2 over radical 2?
2.
2 times 1.
It's 1, right? Anything divided by itself is always 1, correct? So I'm multiplying this blue thing by 1. Okay? So if I have...
But it gets rid of the radical, don't it?
Yes, it rationalizes it.
So why can't you just erase the radical?
Because it alters the numerator. If I just erase the radical, I don't have what I need. And because it alters the numerator as well. So what's radical 2 times radical 2? Radical 4, which is 2. Would you guys agree that 2 radical 2 over 2 is the same thing as 2 over 2 times radical 2 over 1? If I multiply those together, do I still get that thing right there? What's 2 divided by 2? That goes to 1, right? So 1 times radical 2, isn't that just radical 2? Okay, so here's the argument, guys. That number right there and that number right there are identical in regards to their quantities. If I type them on GeoGebra real quick, okay? Take 2, divide it by square root of 2. Gives me that number right there, right?
Yeah.
Square root of 2, that number again, right? Okay? So they're alternate versions, okay? Alternate formats. But think about why I would do this. I just solved for x, right? What would you rather put right here? Would you rather put 2 over radical 2 and have to cross multiply there? Does that make sense? Or would you rather do that cross multiplying? Isn't that cross multiplying a little bit easier? What's radical 2 times radical 2?
It's 1.
No.
No, that's radical 2 divided by radical 2.
Radical 2 times radical 2 is
2.
2. Radical 4, which is 2, yeah. Okay? So the purpose of simplifying down to that is so that when you use that number in other calculations, in other work somewhere else, in that format that I've circled, it's so much easier, so much more convenient. The algebra is going to be set up for you nicely. Okay? If you don't simplify answers, your math is going to get messy later on. Okay? Now, I know there's a lot of stuff there, a lot of work there. Okay? But your fraction work, guys, that's 6th grade math. Okay? That's a standard in 6th grade math, how to add, subtract, multiply, divide fractions. Okay? Radical work we had through Algebra 1. Okay? You might have been introduced a little bit in 8th grade to it. We need to get better at those things. Okay? We're going to continue to work at it. But please, please, please take the initiative outside of class, if you're struggling with it, to force yourself to get better. Because, yes, these questions are going to go away. We're going to get to a different concept with some triangles here in a little bit. But guess what that concept's going to involve? Radicals. Okay? And then when we get into area, guess what that's going to involve? Radicals. Okay? We just, they're unavoidable. We can't get rid of them. Irrational numbers are of great use to us. Okay? The Greeks a long time ago had issues with their counting system and how to do math because they didn't have irrational numbers in their number line. Okay? They didn't know what radical 2 was. We have it. We have this irrational set of values, and they become very, very useful to us. I'm going to stop there. If you guys got questions tomorrow, about 3.